Greetings, math fans. All right, so this is day 3 notes for the second part of sequences and series. And what we're going to do today is actually take a look at the sequence and the series as n goes to infinity. Okay, we've kind of talked about that a little bit in the first part of sequences and series, where we looked at an infinite geometric series. We're going to take just a little bit further now, and we're going to look at the sequence, what happens when that goes to infinity, and we're going to look at series, what makes it go to infinity. Okay, we kind of know a little bit about that, but like I said, we'll get into a little more detail here. So let's kind of start out. You have this nice little friendly note sheet here, and basically, I'm not going to read, well, just kind of reading this thing here. It says the value of a wide variety of terms have been calculated for you. So what I'm trying to show you in this note sheet is, hey, when n gets really big, when you have a sub 1, a sub 2, if you look at the sheet here, a sub 1, a sub 2, a sub 3, a sub 10, a sub 20, a sub 200, when n gets really big, what happens to a sub n? All right, so this first part here, math fans, is my sequence, is the a sub n. And then as you can see right next to it is s sub n. And s sub n, so it even kind of tells you here, a sub n represents the nth term so of the sequence, and s sub n represents the sum. Right? We talked about series, right? The sum of the terms up to the nth term. So basically, this is what you're given right here. Here's your general expression, no saluting required. All right, so I have a sub n equals 3n plus 2, and then I plugged in values, so we didn't have to plug all these values in the calculator, but truly you can just plug it in your calculator. But I'm saying, well, what happens when I plug in a 1, and what about a 2, and now a 3, and then a 10? And you can see what's going on. The first, if I plug in a 1, I get a 5, and then I get an 8, and then 11, 32, 62, 602. Right, it's getting bigger and bigger and bigger. So I'm saying as n, that little arrow means approaches. Okay, so this is kind of important. This guy it approaches. So it's getting bigger and bigger and bigger. It's approaching infinity because you can never get to infinity, right? The only thing you can approach it. Now, I've been to infinity a few times, but most people don't even get there. Okay, and Buzz Lightyear, one of my buddies, he's actually been beyond it, which is really weird. Anyway, as n gets really, really big, what happens to a sub n? It also goes to infinity. All right, and what happens to the sum? Well, you can see the sum is 5, and then you keep adding it up. 13, 24, 185, 670, 60,700. That's also going to infinity. All right? Well, that's these are both going to positive infinity. Let's take a look at number 2. Again, when n is getting bigger and bigger and bigger, of course, it's when I multiply by negative 2, it's going to negative infinity. And s sub n is also going to negative infinity. Okay, so underneath here it says what type of sequences represent in number 1 and number 2. Well, you guys should recognize it, right? It's a sub n equals 3n plus 2, and a sub n is equal to negative 2n minus 1. This is from, again, the first part of sequences of series. These are both arithmetic. Okay, that's important. All right, so let's take a look at the next group here. What type of sequences is represented below in number 3, 4, and 5? Well, you guys should recognize this is, right, a sub n equals a sub 1 r to the n minus 1. So this is definitely geometric. And now let's kind of analyze a little bit. Well, for the first one, do you guys agree r is equal to 2? Because, right, we're looking at the a sub n equals, right, a sub 1 r to the n minus 1. So a sub, or r is 2. Let's just look at number 4, r is 1. And number 5, r is negative 1. Okay? So let's kind of fill it in now. Again, you kind of analyze a little bit, right? What happens when n gets really big? What happens to the actual sequence of numbers? Well, it's getting bigger and bigger and bigger. So that one's going to infinity. And what about the sum? Well, obviously, if their numbers are going to infinity, the sum, when you add those numbers up, that's also going to go to infinity. All right? Number 4, what is a sub n approaching? Okay, well, isn't it 3 for every one of these? Because it's basically 1 to whatever power is still 1. So this is actually approaching 3. And what is the sum? Well, if I keep adding them up, 3 plus 3 plus 3 plus 3 plus 3 plus 3, I'm getting bigger and bigger and bigger, and I'm going to infinity. All right, sometimes people look at this and they tell me, well, the sum's approaching 600. Well, no, I mean, I gave you the second, or the term number 200, the sum of that. I can give you term 400, it's going to get bigger and bigger and bigger. So I'm just trying to show you big numbers, and it keeps getting bigger. Okay? Number 5, as n approaches infinity, what happens to a sub n? Well, here's the deal, math fans. If it fluctuates between a negative and a positive value, it's not really going to negative infinity, it's not really going to positive infinity, so we say this does not exist. That's what D&E does not exist. Okay, DNE. Or if you're, eating some random place and you're not supposed to eat at that random place, then do not eat. Okay, kind of like don't eat pencils. Okay. And then what happens? What is the sum going to? Well, do you guys agree that the sum is going between, if I say 3 minus 3 plus 3 minus 3 plus 3 minus 3, right? I keep going back and forth. You can see the sum. Sum is 3, 0, 3, 0. Then it fluctuates between basically 3 and 0 because I'm either adding 3 or subtracting 3. So that is not approaching anything either. So that is also does not exist. Okay, not bad. So the thing that I want you guys to keep in mind for this is what's going on here. If it's going to infinity, this is r is 2. This one's r is equal to 1. R equals negative 1. So we're going to get to these problems a little bit to discuss them, but we want to investigate just a couple more yet. All right. Well, here r is, let me fill these in. R is 1/2. R is negative 1/2. And r is 9/10. Okay, so again, just investigating it. What happens is n goes to infinity. Well, 3, 1.5, 0.75, 0.005, 86, 0.00, and right, a sub 200 is 3.7 times 10 to the negative 60. That means it's point, and then it's 59 zeros, 37, right? It's a really, really small number. So it's approaching 0. And what is the sum approaching? Well, 3, 4.5, 5.25, 5.99, 5.99999. S of 200 is 6, so it actually is approaching 6. Okay, let's look at number 7. It's negative 1/2 is r, and again, do you guys agree that it's getting smaller and smaller and smaller, so it's approaching 0. And what's the sum approaching? Well, it's approaching 2. And for number 8, r is 9/10, and what's happening to a sub 200? Right, it's getting, again, smaller and smaller. It's not getting as small as fast, but it's still getting small. Oh, and I want to point out, look at number 7. Some of you guys may be thrown off when you see a negative. It doesn't matter. If it's negative 0.00001, it's still approaching 0, right? Or positive 0.001. All right, anyway, this is not getting close to a 0 as fast, but it is still approaching 0. And same thing with the sum. You can see, I mean, certainly looking at the first term, the 3 there, and the 5.7, that really doesn't tell me what's going on here. And the S sub 3 is 8.13. It's when I get bigger numbers, like S sub 50, 29.84. S sub 100, 29.9999, 999,203. S sub 200, again, now we're actually rounding, right, to get to 30, but that's what it is. It's approaching 30. Okay? So if I kind of keep going here a little bit, just to kind of talk a little bit what's going on, it says as n approaches infinity, okay, if the sequence or series, so the sequence a sub n or the series s sub n approaches a particular value other than infinity, then a sub n or s sub n are said to converge. So basically, math fans, in order to converge, you are going to approach, it can be 0, or any positive or negative number. Okay, but it's one number. Okay, it's got to be a particular value. So any of those, it says basically we converge. That's a really important word. So if you're approaching a value, you're converging to that value. It's kind of like if I said, hey, let's all converge to Dairy Queen. That means we're going to Dairy Queen. Okay, we're going to all show up at Dairy Queen. If I said everything's converging to this number, then everything is going towards 5 or 7 or 0 or negative 1.2 billion. Okay? And then number 2, it says if the sequence a sub n or the series S of n does not approach a particular value. And what that means is, let me write this out here, approaching not a particular value is approaching infinity, negative infinity, or if it goes like plus a number, plus positive 5, negative 5, positive 5, negative 5. Okay, so if it's not approaching a particular value, we say it diverges. Okay, very, very important word. Converge means you're converging on something, you're going to a specific value. Diverge means there is no value. I'm either going to infinity or I'm going to positive, negative, fluctuating back and forth. Really, really, really important. All right. So the next part says use the words converge or diverge to complete the following statements. Look at examples 1 and 2, which are arithmetic sequences. Okay. So then it tells you an arithmetic sequence and an arithmetic series. Well, let's go back here and look. The first ones were arithmetic number 1 and 2, arithmetic sequences and series. And you can see it's always going to diverge because they're either going to go to positive infinity or they're going to go to negative infinity. That's what happens because you always add, if I keep adding a number to it, it's going to get bigger and bigger and bigger. All right? So I would say that, going back to this guy right here, an arithmetic sequence will always diverge. Always, always, always. And an arithmetic series will also diverge. Okay, now math fans, what we're going to do is we're going to take a look at examples 3 through 8 that we just filled in, which are geometric series. And what we need to do is we need to pay close attention to the values of r. This is so key here. We've got to pay attention to the values of r. All right, so for the first one, it says if absolute value of r is greater than 1. What that basically means, if the absolute value is greater than 1, that means r is got to be greater than 1 or r is less than negative 1. So basically if it's, it can't be in between and it can't be equal to because we're going to get to the two examples below there, but r has got to be greater than 1 or r is going to be less than 1. So let's go and take a look at that example. In fact, that's going to be, it'll just be nice to number it here. That's going to be example number 3. So I'm just going to put a 3 here for you to look at. All right, and let's go take a look at that. So if r in number 3, r was 2, and what's going on with both of these? They're both diverging, right? They're both going to infinity. You can see they're getting bigger and bigger. So we're going to go back down here and fill this in. The sequence will diverge. And the series also diverges. Okay? The next one, r equals 1. That's example number 4. Let's go back to it. You can see what's going on is the sequence is actually converging to a sub 1. Do you guys see that? I mean, here's a sub 1 right here. And it's converging to the very first term. All right? And what's going on with the sum? Well, that's diverging. Okay? So I come back to this guy here, and the sequence will, like I said, it's going to converge and basically to the first term. And the series is going to diverge. Okay? R equals negative 1. That's going to be example number 5. So let's go back and take a look at that one real quickly. And you can see what's going on. A sub 1, a sub 2, right? It's going 3, negative 3, 3, negative 3. Okay, so that doesn't exist as you go to, as you look at this, the sequence and the series, because they both fluctuate between like 3 and negative 3 or 3 and 0, right? Back and forth, back and forth. So they both those guys do not exist, which means sequence will diverge and the series will diverge. Both. Okay? This next one, if r is, absolute value of r is less than 1, that means r is between negative 1 and 1. Not equal to, but between it. So it's basically some fraction between negative 1 and 1. So that is actually example, it's next several examples, that's going to be 6, 7, and 8. So 6, 7, and 8. Okay, so let's take a look at those. you can see, like for 6, it's 1/2, 7 is negative 1/2, and 8 is not quite 1, but it's 9/10. So it's still between negative 1 and positive 1. And you can see what's going on with the sequence of numbers. They're all approaching 0. So it's converging to 0. So let's write that in there. Let's do one at a time here. So the sequence will converge to 0. And the series, well, what's going on with the series? Number 6, it's going to 6. All right, let me highlight that, right? This is going to 6. For number 7, it's going to 2. And number 8, it's going to 30. Well, so that's actually converging to a number. So I'm just going to write the word converge here. Let's talk about how we actually get those values. So this is going to converge. And guys, this is from last chapter. What if it's, and basically I'm saying that series, it's going to infinity, so S sub infinity. Do you guys remember what we learned last time? And this is only when r is between negative 1 and 1, and you have your infinite geometric series, a sub 1 over 1 minus r. So that actually goes in this little box here. S sub infinity is equals to a sub 1 over 1 minus r. That's an infinite geometric series. That's why this converges to that number. Okay, so if I just to do one of them here, if I look at this guy, let's look at number 8. S sub infinity equals a sub 1, which is 3, right? We put a 1 in there for n. It's 9/10 to the 0 power is 1, so it's 3 over 1 minus 9/10. So basically 3 divided by 1/10 is 30, which, if we come back down here, right, is this guy right here. It is going to a 30. We kind of looked at the series, figured out it's going to 30, but truly we could have used a nice little friendly formula. S sub infinity equals a sub 1 over 1 minus r. So that's a nice little friendly formula that you'll use to figure out the sum of a series. It's the only one where you had to kind of do a little bit of figuring out. Otherwise, things go to 0, or they go to the first term, or they go to infinity, or they go back and forth where it doesn't exist. So a lot of different possibilities, all right? So basically, again, what I'll do is I'll give you a sequence, general term, and I'll say, tell me about it. Does it diverge? Does the series diverge? And if it converges, what does it converge to? Okay? So let's take a look at some examples here. Okay, given a sequence of numbers, determine if the sequence is arithmetic or geometric. If geometric, give the value of r. Then determine if the sequence and the series converges or diverges. If a sequence or series converges, tell what it converges to. All right. So a lot of little things here, but that's okay. Let's go through it here. Not a big deal. It says circle one. Well, you can see that this goes 3 to 6 to 12. So it's going up by multiples of 2. So it's definitely geometric. And r is equal to 2. Because you can even divide it out. 6 divided by 3, 12 divided by 6, 24 divided by 12, etc. R is 2. So you guys should recognize, again, based on what we just filled out, what is the sequence? Does the sequence converge or diverge? Well, it diverges because it's getting bigger and bigger and bigger. And what does the series do? Well, the series also diverges. And again, I'm just using this chart up here. Okay, but again, hopefully you recognize that you can even look at the sequence of numbers here. It's getting bigger and bigger, and then if I add them together, it's going to get bigger and bigger. So they're both going to go to infinity. And sure enough, when r is 2, which is like this first case scenario over here, like this guy right here, right? That is what we're just talking about. And then, of course, it's going to diverge. Okay, let's go to the next one. Negative 8, 4, negative 2, 1. So again, if I test this out and I find the value of r, because I see it's not d, it's not arithmetic, so r comes out to be negative 1/2. Okay, and of course it's geometric. So what does the sequence go to? Well, you can even see what's going on with the sequence. I don't want you guys to say d and e because it looks like it could be d and e, but it's not. It's going negative 8, 4, negative 2, 1. It's getting smaller and smaller and smaller. Even though it's going back and forth, it's still going back and forth, smaller and smaller and smaller, and eventually it's going to converge to 0. Okay, and because it is, I'm looking for or the r is between -1 and 1, I can figure out my sum, or my series, s sub infinity is equal to a sub 1, -8 over 1 minus a -1/2. Okay, using our nice little friendly formula, a sub 1 over 1 minus r, and then make sure you put that in parentheses, and that is also then going to converge to -16/3 if you put that in your calculator. All right, let's keep going here. Number 3, 12, 5, -2, -9. I mean, again, I think the first thing I do is I just test it out to see what's going on, and I see I'm subtracting 7. So d is equal to -7. So it's definitely arithmetic, and as soon as it's arithmetic, you know this is going to it's going to diverge and diverge. That's what it is. Arithmetics always diverge, diverge. Okay. Number 4, -4, -4, -4, -4. Definitely geometric, and r is equal to 1. Because -4 divided by -4 positive 1 divided by -4 positive 1, right? So, of course, what is the sequence? Again, be logical. Look at it. What is the sequence going to? Well, it's converging to -4. And what happens if I keep adding that over and over, -4, -4, -4, -4? It's going to get more and more negative, so it's going to diverge, not converging on anything. Okay? And again, don't tell me it converges to -infinity because that doesn't make sense. It converges to a number, 0, 5, -1.2 billion, but never to infinity. That's diverge. Okay? Number 5. -408, -1632. Well, if I do this, I can see that r is equal to -2, so it's geometric, and r is -2. So what's going on with the sequence? So you guys agree it's getting bigger, but negative bigger, positive bigger, negative bigger, positive. It's fluctuating back and forth. So it's actually going. If I ask you what's it approaching, it's d and e, right? So it's going to diverge. And what happens when you keep adding and subtracting a positive, negative, positive, negative? Again, it's going to fluctuate back and forth, and that's also going to diverge. And again, this is if r is -2, you can kind of look at one of our charts here. R is -2 is going to be just like the one I just highlighted in green here. They're both going to diverge. Okay. All right. Number 6. If I divide, I can see that r is equal to -1. It's geometric. And what's that going to? Well, you can see again the sequence is 4, -4, 4, -4, 4, -4. So it's going to diverge because it's really d and e. The limit as n goes to infinity, right? And of course, what's going on with the series? Well, 4 minus 4 plus 4 minus 4 plus 4. So it's going to go 4, it's going to go to 0, back to 4, back to 0, 4, 0. So it's also going to diverge. Okay? And then the last one, again, if I divide this out, I can see r is equal to -1/2. So -1/2, and of course, it's geometric. So the sequence is going positive, negative, but it's getting smaller and smaller and smaller, so it's actually converging to 0. And once again, math fans, this is between -1 and 1. I said, hey, what's going on when it goes to infinity? You're going to use your nice little formula. S sub infinity equals a sub 1, which is -1/3, divided by 1 minus r, -1/2. And if I do all that work, I get -2/9. That's what it's going to converge to. Okay? So I try to give you an example of each one where it's arithmetic, one where it's geometric, where r is equal to 1, where r equals -1, r is between -1 and 1, r is greater than 1 or less than -1. Try to give you a scenario of each one of those to hopefully get you guys to understand what's going on with the sequence and the series as n goes to infinity. Okay? So that's it, math fans. That's just, like I said, day 3 is basically just investigating that infinite sequence and infinite series and understanding the word converge and diverge. Converge means you approach something. Diverge means I'm either going to infinity or fluctuating back and forth, positive, positive, negative, positive, negative, positive, negative, etc. Okay? That's it, math fans. Have an outstanding day. Adios. Goodbye.